can quick. All right, we are going to talk about exponential and logarithmic equations today and solving equations. So the good news is the notes anyway are not application problems at all. We're just going to work on basic algebra, okay? But it does involve logarithms and exponents. Okay, we are going to actually start, yes, with this worksheet. It looks like this at the top, 23A. Okay? Everybody got it? I passed it out. 23B is Newton's law of cooling. It goes with an application packet that I'm going to give you possibly tomorrow to get started on, but we probably won't talk about Newton's law of cooling and the actual applications till the earliest Friday, possibly Monday, okay? Because it's not on the homework check. That packet is not. All right, let's start here. It says if you have a problem with a single power of x, you want to isolate that part of the problem, do your Algebra 1 skills first, and then use a reciprocal power to solve that. So here we would do what first? Divide by 15. And then we need to get rid of a 2/3 power, so we're going to raise both sides to the reciprocal of that, which is the 3/2 power. Okay? This will become 6/6, or just x to the 1. This is really the square root of 4 cubed, which is, anybody? 8. All right, algebra first. What are we going to do over here? That's 1.2, sorry. We could make 1.2 a fraction. Anybody know what it would be?
I don't think 57 got
Oh, yeah, thank you, it's 19. Let me just rewrite that because it doesn't look good anyway. Thank you for clearing that up. Okay, 1.2 is 6/5, so the reciprocal would be 5/6. That's great. If you're lazy, can you type 1 divided by 1.2 as the reciprocal? Yes. So if you want to just do the reciprocal is 1/1.2, it will work on your calculator. Your calculator is your friend. And I don't, it's 11 point something, I only remember from last period. What does it come out?
11.6.
One more decimal at least.
Oh, 3.
Okay. If you put 11.6 back in, can someone do that for me? 3 times 11.6 to the 1.2?
56.8.
56.8, okay? So the more decimal places we put in, the more closely it will check with 57. Does that make sense? Okay. I'm not going to be super picky. Please use at least 2. I will use 3 or 4 on some of these problems just because they are more accurate. Because most of our answers are ugly decimals on these. All right, next section talks about when you have a single exponent with a variable in it somewhere, okay? So you have a single exponential expression, an x somewhere in the exponent or whatever the variable is up in the exponent. You want to isolate that term, and then you're going to take the log of both sides, or some teachers teach this as exponentiate, but we're just going to do the log of both sides, I think. So what do we want to start by doing here? Okay. Algebra says we're going to divide by 50. Somebody help me out. 25?
Yes.
Okay. Then we need to do the log of both sides. And it doesn't matter if you do LOG or LN. Just do one that's easy. You can do the log base 7 of both sides if you really want, but who wants to do all that extra stuff on their calculator? Okay? What do we need to do next, though? We want to put that guy out front, right? And then we just need to do some dividing. If we divide by the log of 3, and when you type that, you do have to close your parentheses there. You have to hit log twice, there's no shortcut. Log 25 divided by log 3. You'll get a decimal, but then you need to divide by 2. What is it before you divide by 2? Somebody have it?
2.929.
And then after you divide by 2, 1 point, something like that? Are we close? Right, can you try the next one on your own? Caitlin, do you have a calculator? You need to borrow one? Got one? Yeah. This is an ugly decimal from the beginning, I think, isn't it?
4 divided by 33. 430.
Yeah, this is 4 divided by 33 or something if you do a fraction, otherwise it's like 0.121212 or something. Honestly, I was lazy and just left it like this. Then I took the log of both sides, brought the x out front. And then divided this log of 0.8 divided by 6.6. And then that close parenthesis, divided by the log of 0.5. Anybody?
3.14.
Anybody not getting that?
Yeah, a little bit different, but it's still the same thing. Why not just take the log base of 0.5 on both sides?
When you get to here,
Yeah.
I don't care if you do them that way, Zach. The reasoning is that if you have to use a scientific calculator in a science class, or you have to do this without, you know, most calculators don't do log of other bases, only 10 and e. Does that make sense? Are you getting the same answer? You do it, yeah. Most calculators will only do log, log, or ln. They don't do log base 0.5 or whatever, okay?
But then you say you just do the bigger
The
number.
change
one
of
number.
base, yeah, you can, yeah, absolutely. All right, on this one, there's a little bit of a shortcut we could do. If we divide by 150, what do we get?
600.
You did a 45 x with 600.
Okay, which kind of log do we want to use on this one? If we do ln, then when we bring the 0.5x out front, the ln of e is just 1, right? So that'll take care of itself. You don't have to type anything. So then you divide both sides by 0.5. ln of 600, close your parentheses, divided by 0.5 is? Everybody all right? Okay, moving on. The next option is you can have problems that have log 1 time. Now, this problem is taught differently if you have Ms. Abruzzo versus me. I will talk about both, okay, and I'm not sure how like Mr. Hardy or Mr. Greger. I just talk about rewriting this as an exponent problem, because what's the base right now? 10. So I'm going to say that this is 10 to the third equals 2x plus 20, okay? When they teach it in Algebra 2, sometimes they do this. They say, I'm going to exponentiate both sides, so I'm going to make this 10 to this power and 10 to this power, and the 10 and the log take care of each other over here. So you have 2x plus 20 equals 10 to the third. Is that exactly what I did? Yeah. Okay, but whichever way you want to think about it. They say I'm going to make both be exponents of 10, so then it comes out to this anyway. All right, this is 1,000 minus 20, right? Divide and we get 490. Did I go too fast? Are we good? Everybody's already done with that one? What about this next one? Divide by 3 first. You can put it as a cubed, but no. You're just making yourself a whole bunch more work. Yeah. You want to do, to get, for the natural logical way, you want to rewrite it as a base E, or you want to do a base E on both sides. Okay? If you did this to both sides, these would undo, and you'd have x plus 2 equals e squared. Same thing. So it's e squared minus 2, whatever that is. If you wanted an exact answer, that's what you would write down. Anybody have a decimal for me? Sorry.
5.3.
Thank you. I heard too many voices on top of each other. Sorry. Everybody agreeing that that's the right answer, though? All right. The next possibility, the final possibility, is that we have two logs that are being added, subtract, multiply, or divide, and we need to try to compact that into one. Okay? So the first problem, if we compact that addition into a single log, what will we have? Right? Two separate logs added become one log multiplied. This is indeed 2x squared. Now we need to go back and use one of the methods we've already talked about. We have one log, so I'm going to rewrite it. You can think of it as raising each side to the 10. Okay, you can do this if you want. I'm just going to say 10 to the third equals 2x squared, sorry. So you get 1,000 divided by 2. Now normally we'd have plus or minus the square root of 500 and some decimal, or that would be 5 times 100, so 10 square roots of 5 if you wanted exact answer. You go back to the very beginning, sometimes a negative works, but on this problem, can you put a negative in and take the log of negative something? You can never take the log of a negative number. So the answer here is just 10 square roots of 5 or whatever decimal that's equal to. You can't have a negative. But we will have some with two solutions, so be careful. All right, what do you want to try in the next one? Okay, condense it first. How do you want to start condensing though? Where can we put that to? As a squared? Everybody good? And then the minus becomes a division, so we have the natural log of x squared over 3 equals ln of 12. Now, we don't need to rewrite this. The only way two logs are equal to each other is if the part is equal to each other, right? Yeah, we can get rid of the logs on both sides. Basically, you're doing this to both sides, so this cancels, okay? Whichever way you want to think about it. They just have to be equal. And there's a property, your notes call it some particular property that allows you to say you can get rid of the logs. All right, now if we multiply by 3, we have 36. We square root, we have plus or minus 6. Now, if this had started out the log of x squared, the natural log of x squared, we could put a negative in it, because you can square a negative number right off the bat and get a positive and then take its log. But it didn't start out that way. It started out 2 times the natural log of x. Can you take the natural log of a negative number? Anybody?
No.
No? So the answer is just positive 6. All right, can you try these next 4? Anybody, somebody else want to come up and do one? You don't have to explain, you just want to write? Yep, you can do the next one, Sean, yep. Try to beat them, guys. Get it down on your paper.
I can try it.
It's one of the ways up above.
What did you say was one
We are gonna do a few examples off 19 and 20, just the guided practice. I'm not gonna go through the examples that the book already explains there. And then I'm gonna go over what's on the quiz. Okay? Okay. Amber didn't show the first step, she just went straight to 150 divided by 60 is 2.5, everybody okay with that step? Then she did the natural log of both sides. Then she changed this to a decimal and brought this out in front, but the ln of e is just 1, so she had 0.2 t equals 0.92 and divided by 0.2. I would have done more decimals along the way, longer decimal places so that it's more accurate, but she didn't do anything wrong. Probably rounds to the same thing no matter how many. Better, more places, but if she rounded to 0.92, it just rounds to 4.6 at the end anyway. Go ahead, Sean, next one. Is it round to 4.6 no matter what? Is it close?
Pretty much.
4.59?
4.581.
Okay. Work is a little confusing right here, but divided both sides by 4, got 17.5, and then to get rid of the 0.4 power, did a reciprocal 1 over 0.4 on both sides. And I understood what you meant, that this was a reciprocal, but there shouldn't be a 1 there either, it's just 1 over 0.4. You're fine. Okay, I'm just gonna write it like that. Everybody okay?
They have like a really,
What?
they have like a really, like a long number with like an E in there.
17.5 to the 1 over 0.4?
Yeah.
It's not 0.04, it's just 0.4.
Oh.
0.4. Better?
Can you write like kind of just like the steps again, just so I can see how?
Yes. Divide by 4. And that came out 17.5, okay? And then 0.4 is the 2/5 power, so you need to do the reciprocal. So you could do to the 5/2 power. We were just lazy and wrote 1 over 0.4 because this would be 0.4 times 1 divided by 0.4, which would just be 1. So then 17.5 to the 1 divided by 0.4 all up in the exponent. Or if you're using an older calculator, you would need to do it like that. Okay?
Your last time. No, turn it around.
At all, or just when I was talking to Brendan right then?
Times, but.
All right. I'll try to talk louder.
Can I borrow a pen?
Yes, help yourself. Somebody want to put 3 or 4 up here quickly? No? You want me to? What did you do here? This is a really basic one. Compress these two into what? And then we can get rid of the log on both sides. Remember, you can only get rid of the log, guys. You can only get rid of the log on both sides if you're down to 1 log on both sides. I sometimes have students who want to just cross out all the logs here or something. Can't do that, okay?
Watch me.
Okay, you can, but you get it wrong. How's that? What do we want to do on this one? Divide by 3 first would have been my answer. 2 log of x over 2 equals 2. Rewrite it. This is a base 10. So we have 10 squared equals x over 2. That's 100. And to get rid of divide 2, you multiply. So everybody got 200? We good? Okay. Can you please take out worksheet 19? Okay, you don't have the cute picture of the turtle. I really like the turtle, so I left him on my slide. Something about that just makes me relax. That underwater thing. I don't know. All right. This is the property I was talking about a minute ago that says you can get rid of, guys, if you have 3 to the x equals 3 to the 5th, then x has to equal 5. Okay. If you had, it's not very good. If you had log of 6 equals log of x, then x would have to equal 6, that kind of thing. Okay. They go through some examples, but this is actually a concept that we did not cover on the notes yet. Because in our old book, it's in a different section, I think. We've done a couple of these, though. Anybody know what we need to do?
Was 16 as in 2 to the,
Yeah, we could rewrite, we need the same base, okay? We could use 2, or we can just use 4. Yeah, on this one, I would just use 4. You can make these both powers of 2 if you want. I just did, this is 4 squared. Now, what do you do when you have exponents power to a power? You multiply. So this becomes 2 times x plus 3 equals 4x plus 7. Remember just a minute ago I showed you that property that said if they're both the same base, then the exponent powers have to be the same, so I just got rid of the bases. Now it becomes an algebra problem that you can solve faster than me, I bet. Everybody get negative 1/2? Okay. This one's a little tricky. What happened, I'm thinking they're both powers of 2s and 3s, right? So I left this one alone. But what do I need to do to that one? I need to flip it over, so that will make it negative, right? So then it'll be 4/9 to the negative 1 is the same as 9/4, but they're both squared. So if I wrote 2/3 to the negative 2, would that be okay? You'd square to get a 4 and a 9, and the negative would flip it over? Because it has to be a 2/3. I need them both to be 2/3. I need them to have the same base, okay? So this one was a 2/3, I needed this one to be a 2/3. That was my explanation over there. So now I can get rid of the 2/3 and write x minus 5 equals negative 2 times 3x over 4. And that's all that is. Negative 2 times 3 divided by 4 is? Did I do that right? Negative 1.5 or negative 3/2? No? Oh yeah, we got an x. Thanks. Lost my x. Now if I subtract this 1x, I'll have, so I got positive 2. Did anybody get a positive 2?
Wait, is that still negative 2.5? Negative 2.5.
Negative 1.5x minus 1x is negative 2.5x. If I put in a 2, I get 2/3 to the negative 3 equals 9/4 to the 6/4 when I put in a 2. What's 6/4? Did I do something wrong? Is this checking or not?
Why is it the 1.5 with the x? Because it's just
What? Yes?
So why wouldn't you say 1.5x?
You gotta move the x's to one side and the numbers to the other side. And negative 1.5 minus 1x is negative 2.5. Everybody's lost on the algebra. We okay? Okay, if I put it back in, this is 2/3 to the negative 3, which becomes 3 cubed over 2 cubed, which is 27 over 8. Did I do that right? Okay. This side is 9/4. If I reduce 6/4, I get 3/2, which means I have to square root 9/4 and then cube it. What's the square root? 3/2, and when I cube it, I get 27 over 8, so it checks. That's a miserable problem to check, at least. All right, let me see if I can undo some of that so that my notes aren't so messy for. All right. I'm going on to. Do we need to do any of these? You understand how you'd start all those? Let's do this one real quick. How would you start 2C?
3 to the 4th is equal to x squared minus 1.
That's how I would have done it. Okay? I was really happy because 81 is a perfect square, but it's not 81 anymore, is it?
It's 82.
This is 81. So it's 82. I don't know. I think that's just 4 times 21, so 2 squared roots of 21. Or some decimal. Anybody have the decimal for me?
20 and a half.
What?
82 divided by 4 is 20 and a half.
Yeah.
Yeah.
Oh,
Square root's not-
there's nothing that goes in there then. To 82, right? 2 and 41, so it's just a decimal? So what's the square root of? Thank you for fixing me.
Square root of 80.
Plus or minus square root of 82?
Or 9.
Okay. Can we throw away the negative?
Yeah. Wait, the negative can't go in the
Look at the problem, guys. The first thing you had to do was square the x. So does it matter if we put in a negative? No, it's going to become positive 82 as soon as we square it. So this one does have 2 solutions. Don't be too speedy to throw away negative solutions. All right, I'm skipping down to this. I need somebody to tell me which page I'm on. This is 20A.
Yes.
Okay. Yep, on this one I can just get rid of the logs. So I have 2x equals x squared minus x plus 2. I have to make it equal to 0, yes? And factor? So we get 2 answers. 2 or 1, any reason to throw either one of them out? You can put them back in, you get 4 and 4. If you put in a 1, you get 2 and 2, so no, they work. What about this one? We gotta combine those into one log that says what? Then we can get rid of these. Oh, I got 1, 2. All right. Just because it's an idea for tomorrow's quiz, does that check the log base 12 of 1 plus the log base 12 of 4 equals the log base 12 of 1 plus 3, which is 4. What is this? 12 to what power equals 1 would be 12 to the 0. So this is 0. So therefore they are equal. Okay? That's a question that could show up tomorrow with no calculator. Can you evaluate log base 12 of 1? Do we need to go over these? You just rewrite as a log or take the log of both sides, either way, whichever way you want to do it, okay? So you could do y times the log of 8 equals log of 0.165. That's the way I would do it, and then divide. Some of you realize you can rewrite that as a log base 8 of 0.165 equals y, and type that in your calculator. That's just not the way I learned to do them, so I don't do them that way, but it's fine. You get the same answer, I promise. Sure. Did someone else get that answer at all?
Yeah.
Okay. I'm going to move on to another slide. You can do those two if you want. You don't have to. There's a couple of these on the homework. There's nothing nice about this. You're just going to get nasty decimals. Okay? You can't rewrite 6 and 5 as a common power, common base. So you end up just having to do 2x plus 4 times the log of 6. I'm going to use ln just because it's shorter to write. And over here I get a negative x plus 1 times an ln of 5. Okay, then it just becomes a calculator typing question. You can, but you're going to end up with logs all over the place anyway. So the natural log of 6 is 1.792. And that's got to be distributed through here. And over here, the natural log of 5 is 1.609. And that's got to be distributed through here. Yep.
Are there the log of 6 and there's a natural log of 6? I have two different answers.
Yes, you're going to get 2 different answers. You have to pick to do one on both sides, Amber. It'll turn out the same at the end as long as you do ln on both sides or log on both sides. Okay? You just can't do one on one and one on the other. You will get 2 different decimals along the way, but it'll turn out the same. Yeah, it's kind of weird. 1.792 times 2. Okay, tell me if I made a mistake somewhere. Negative 1.07? I think that's what I got last period.
Yeah, that's what I heard.
There's like 2 of those on the homework. There's nothing nice about them, but honestly, you're in pre-calc. I hope you can deal with decimals in an algebra equation, because that's all it becomes.
Wait, can you go back?
Yes.
I just didn't
What time are we done?
35.
Okay. I'm going to do one more thing, and then I'm going to talk about the quiz. All right. I need to talk about this problem. I want you to put your pencil down for a second, because I'm going to show you the way the book does them, and then I'm going to show you the way I do them, and I think you're going to want to do them the way I do them, but maybe not. The book says, let e to the x equal u. So this becomes a u squared plus a 2u equals 8. Okay? The problem is you're not done.
Why?
Because u is still e to the x.
No.
And now you have to take the log of everything and find x. Okay? I don't like that method because it never fails. I write this down and I'm all thrilled I finished the problem. Okay? I don't remember that I have to go back and substitute. So, I don't do them that way. Let's see if I can do the magic circle thing here. All right? What I do is I think of this as my x. So this is going to factor e to the x and e to the x, because if I multiply that, e to the x times another e to the x, you add the exponent to get e to the 2x, okay? Then, I didn't write it out, equal to 0. Factors of 8 that give me 2. We okay? What do you mean what happened? This is my x. I'm just factoring this. It's like an x squared plus 2x minus 8. I just didn't write it out that way because I'm afraid I'm going to forget at the end to do the log. So this was my unknown. I just put it here and here. Okay. This gives me e to the x is -4. E to the x is 2. I can rewrite or take the log of both sides. Now, natural log of e is 1. Natural log of -4 is not possible. So the only answer is this, which is what? 0.69, okay? And you could just write ln of 2 is fine. It's an exact answer that way. So there's a couple like that where you have to factor, okay? Just rewrite it with x's if it helps, but if you use the u substitution, then at the end you gotta remember to still do the solving there. All right, I'm gonna talk about the quiz. This is what's on the quiz. Okay, there are, I'm going to estimate 10 simplifying log questions without a calculator. Log base 2 of 8. So it means 2 to what power equals 8? It's not 4. Okay? It could have, this would be about as ugly as it would get. That's kind of ugly. 1/2 to what power becomes 16? It's going to be negative.
Or you can take the log of both sides.
You don't have a calculator.
Oh, yeah, so.
No calculator. Don't talk that way.
Out loud in my head.
2 times, this is 2 to the -1, right? Okay. So 2 times 2 times 2 times 2, 2 to the 4th?
Use my head and calculate
Okay.
Negative -2 or -4.
So x equals -4 was the answer to this. Well, have to work on some mental math. Okay. There's, guys, there are, I think, probably 4 compact and 4 expand problems. A couple of them are multiple choice, a couple of them are write them out. Do you need an example of each, or you got it? Okay. Expand and compact. Okay, no, that's not it. Then, there are graphing questions. Okay? I will go over the graphing questions, but before I do,
This is no.
yes, the graphing ones are on the no calculator. With the calculator, you also have to do some finance questions, okay? But that's a separate page that you get after you finish the no calculator page. Are we good?
Wait, graphics.
I'm going to talk about the graphing ones. I just want to put that on a separate slide. Okay. Whoops. Okay. You have to graph something like this. Whoa, graphy.
Graphics, gravy.
Okay? One of each. There's no shifting, stretching, flipping, nothing. They're very basic. I promise the bases are 2, 3, 4, or 5. So if you want to go home and memorize all 2, 3, 4, 5, 4, 8 of them, that would be possible questions I'm going to ask. Go ahead, but let me talk about this. You do not have a calculator. So what you need to do is put in 3 numbers. I would pick -1, 0, and 1. What's 3 to the -1 power? 3 to the 0 and 3 to the 1. That should be enough points. -1 up a third, over 0 up 1, over 1 up 3. To give you the idea, you should know the shape of all these, right? They're little loop-de-loop thing, curvy things, right? So this one is doing this. Does it ever cross that axis? They all have an asymptote somewhere, okay? You just got to figure out where it is. It does ask, what's the end behavior? What's the intercept? Was it increasing or decreasing? What are the asymptotes? Okay, this one has one asymptote where? It is the x-axis or y equals 0. I will accept either answer. I can't write x equals 0 because that would be this line. Domain?
Yes.
From negative to infinity?
Range?
Yes.
0 to infinity.
Soft bracket, okay? Etc. Go on to the next one. Log, okay? I just rewrite it, and instead of putting in x's, I put in y's. This is 4 to the y equals x, right? So I put in some y values. If I put in -1, 0, and 1 over here, 4 to the -1 is, 4 to the 0 is, and 4 to the 1? Then I plot those over 1/4 down 1, over 1 up 0, over 4 up 1. Is that enough to give me the shape? Okay, they need arrows on both ends. If you graph them on the calculator, actually, some of you will get them wrong because they look like they end on the calculator, don't they? And they don't. All right, you do need to label a couple ordered pairs, or at least have them over here. I don't care which, okay? That's 4-1. What would this approach as x approaches 0, or x approaches -infinity? Actually, it would have to be 0 because it can't approach -infinity, but it's getting closer and closer to,
Negative infinity. Y approaches.
yeah, -infinity, you're right.
As x
Okay.
approaches 0.
As x gets bigger,
Infinity, it increases to infinity. So really, if you were to write that, it would be the f, if in calculus, it would be f of x to infinity.
as x
As
approaches
approaches
infinity, yes.
Okay. I was just clarifying.
Okay, that's